Regenerative agriculture can transform dying soil into productive ecosystems, and the soil beneath your feet is dying right now. Conventional farming accelerates this process by stripping nutrients, killing the beneficial soil microbiome, and turning living earth into sterile dirt that produces less while costing more. Regenerative agriculture reverses this decline. These 8 techniques rebuild soil from the ground up, transforming degraded land into ecosystems that produce more food with fewer external inputs. Everyone has been verified by university research and confirmed through USDA field studies. The USDA, December 2025 $700 million regenerative agriculture pilot program demonstrates the federal commitment to scaling these practices nationwide. Anyone can implement them at any scale, from backyard gardens to commercial operations. Some deliver immediate cost savings, while others accumulate value over years. All of them work together to create systems that strengthen over time. Technique 1. No-till farming. Every pass with conventional tilling equipment shatters soil aggregates, severs mycorrhizal fungi networks that connect plant roots, and exposes organic matter to oxidation, which releases stored carbon into the atmosphere. No-till eliminates that destruction by planting seeds directly into undisturbed soil, using specialized equipment or simple hand tools. Michigan State University tracked no-till systems for 15 years and found they significantly outperformed tilled fields. Erosion dropped by more than 80%, water holding capacity increased, and carbon accumulated in stable aggregates. A farm documented by American Farmland Trust cut costs by $72 per acre after switching to no-till. In 2016, U.S. farmers using these methods saved more than 812 million gallons of fuel. Sandy and loamy soils show benefits within a few years, but clay-heavy soils demand more patience. Research at the Kellogg Biological Station proved that a single tillage event on previously undisturbed soil erased years of accumulated gains. No-till works as a permanent system rather than a temporary experiment. Technique 2. Cover crops. Fields between cash crops typically sit exposed, allowing rain to carry away topsoil, nutrients to leach into groundwater, and summer heat to bake the surface. Planting cover crops during these periods solves multiple problems simultaneously. Legumes deliver the most value by partnering with rhizobia bacteria that convert atmospheric nitrogen into forms plants can use. Hairy vetch can fix between 38 and 170 pounds of nitrogen per acre, and about half becomes available to the next crop. Crimson clover costs $12 to $38 per acre, while red clover runs $20 to $40 per acre, and both can eliminate synthetic nitrogen applications. Termination timing determines nitrogen release. Cover crops cut during the vegetative stage release nitrogen within 4 to 6 weeks. Penn State researchers established that residues with carbon to nitrogen ratios below 20 to 1 release nitrogen, while ratios above that temporarily immobilize it. Non-legume cover crops like cereal rye and tillage radish scavenge residual nitrogen, preventing leaching. A Cornell study found that tillage radish captured 172 pounds of nitrogen per acre. Home gardeners can broadcast crimson clover or field peas after harvesting vegetables, then cut at ground level in spring and plant directly into the decomposing residue. Technique 3. Composting. Composting transforms waste into soil amendments that improve every soil function through bacterial, fungal, and actinomycete activity that creates humic and fulvic acids, stable forms of organic matter that enhance soil structure and nutrient availability. Compost creates soil aggregates that allow air and water to circulate freely while retaining moisture. Well-structured soil resists compaction, drains during heavy rain, and holds water during dry periods. Oregon State University Extension recommends mixing 1 to 2 inches of finished compost into the top 6 to 9 inches of soil. Surface mulching requires 3 inches. More than recommended amounts cause nutrient leaching and fertilizer burn symptoms. Biochar, another carbon-rich amendment, works synergistically with compost to enhance carbon sequestration and improve soil water retention when applied at rates of 5 to 10% by volume. Fast composting at 130 to 150 degrees with regular turning produces finished compost in 6 to 8 weeks, while traditional piles take 3 to 9 months. A 2025 EPA report confirmed that applying compost improves soil health, sequesters carbon, and reduces stormwater runoff. Technique 4. Mulching. Mulch blocks sunlight and moderates temperature while preventing evaporation. Michigan State University documented temperature regulation of 18 degrees Fahrenheit in mulched soil. This moderation keeps moisture consistent because evaporation drops significantly. 2 to 4 inches of mulch suppresses weeds. Wood chips work well for perennials at 4 to 6 inches, while straw suits annual vegetables at 3 to 4 inches. Keep mulch away from plant stems to prevent rot. New beds need 3 to 4 inches initially, then 1 inch annually as bottom layers decompose. Fresh wheat straw and sorghum Sudan grass release allelopathic compounds that inhibit weed germination for several weeks. Municipal waste facilities often give away wood chips. Autumn leaves are abundant, and arborists may deliver chips free if you are near their work sites. Technique 5. Crop rotation. Growing the same crop repeatedly depletes specific nutrients, builds pathogen populations, and allows specialized pests to establish permanent residence. USDA research documented that diversified rotations increased yields by an average of 20% compared to monoculture. Iowa State found that 3 to 4 year rotations delivered similar economic returns while improving soil health, decreasing erosion, and reducing fertilizer requirements. Rotate by nutrient needs. Heavy feeders like corn, then nitrogen-fixing legumes like soybeans, then wheat or cover crops. Rotate by plant family to prevent disease buildup, since tomatoes, peppers, and eggplants share common pathogens. Deep-rooted crops like alfalfa extract nutrients from lower layers that return to topsoil when they decompose, feeding future shallow-rooted crops. Timing rotations around pest life cycles provides natural control. Corn rootworm larvae starve when soybeans occupy the field instead, crashing pest populations without insecticides. Home gardeners can divide growing space into 4 sections and rotate plant families annually. Technique 6. Integrating livestock for soil health. Rotational grazing mimics natural herd patterns, moving animals between paddocks according to grass recovery rates. It provides natural fertilization. Animal hooves help incorporate organic matter into the soil without tillage, and well-managed grazing increases soil carbon storage. A global meta-analysis confirms that rotational grazing systems accumulate significantly higher soil organic carbon than continuous grazing methods. Scale does not limit application. Large operations move cattle through paddocks, small homesteads use mobile chicken coops, and urban gardeners can keep rabbits or composting worms. Chickens in mobile coops consume insects, scratch up weeds, and deposit nitrogen-rich manure. Moving the coop every few weeks opens sections for planting, with immediate fertility boosts. Multiple species grazing increases benefits. Cattle consume tall grass, sheep prefer shorter growth, goats eat woody plants, and chickens clean up insects. Parasites that affect one species rarely transfer to others. Technique 7. Minimize soil disturbance. Soil functions as a living ecosystem, where bacterial colonies, fungal networks, and soil fauna like earthworms took years to build. Tilling destroys them within minutes by breaking fungal threads, disrupting communities, and exposing organic matter to oxygen. 30% of U.S. agricultural land operates without tillage, but University of Wisconsin researchers argue that number needs to double for meaningful improvements. Beyond eliminating tillage, minimize all unnecessary manipulation. Use permanent pathways to concentrate foot traffic, and when loosening is needed, use a broad fork that lifts soil without inverting layers. Sheet mulching establishes new areas without digging by laying cardboard over vegetation, then covering with 4 to 6 inches of compost and mulch. Plant directly into compost while cardboard decomposes and roots penetrate downward. Clear spent plants by cutting stems at ground level rather than pulling roots. Leaving roots to decompose feeds organisms while creating channels for water and air. Technique 8. Diverse plantings for complementary functions. 9 plant species account for 66% of global crop production, which represents a catastrophic oversimplification. Natural ecosystems contain hundreds of species, each filling a specific niche. Different root depths explore separate soil layers, varied growth patterns create shade and windbreaks, and diverse bloom times ensure continuous pollinator food. The Three Sisters system demonstrates this. Corn provides climbing support, Beans fix nitrogen, and squash shades out weeds. Companion planting applies similar logic. Basil repels pests from tomatoes, marigolds, deter nematodes, and interplanting carrots with onions provides mutual protection from specialized flies. Perennial systems benefit from permanent understories. Clover or vetch under fruit trees delivers continuous nitrogen, stabilizes soil, and provides beneficial insect habitat. Begin by adding 1 or 2 companion plants to existing beds, observe what works, and expand gradually. Gardens become more productive and stable as diversity increases. These 8 techniques function as a system where each component strengthens the others. No-till protects soil structure, cover crops add nitrogen, compost builds organic matter, mulch conserves moisture, rotation prevents pests. Livestock cycles nutrients, minimal disturbance preserves biology, and diversity creates resilience. Choose one technique, learn how it responds to your conditions, and add another when the first becomes routine. Each improvement compounds previous benefits. What this requires is time and attention rather than money. Many practices reduce costs and all build long-term fertility that accumulates as an appreciating asset. Conventional agriculture extracts until nothing remains, while regenerative systems build fertility that increases over decades. The research is established, the techniques are proven, and the results are measurable. Your soil is waiting.